Hey guys, Catlin here with your help for Cool Down 14. This is for our algebra class. Remember, we're going to cover lesson 15 in class tomorrow, so you don't have to worry about doing that one and having that ready. We'll do it in class together at the end of class, and we'll turn in your homework. Okay, but I want to give you some help on 14, which we covered today. We're completing the square, but now we're noticing that the lead coefficient is not a 1. So we have a strategy for that. And if this is not a perfect square, you can make it one, but this one is a perfect square, and that's probably the ones that I'll choose to give you on quizzes or something. I'm not going to make you do that extra step because next week's quadratic equation and formula is going to knock that out with no problem. But if we have a perfect square in the lead term, it's possible it could factor out as two perfect squares. So let's see what this one would look like. Since that lead term is a 4x squared, okay, think of your diagram. You know this is 4x squared. So what two numbers did you multiply to get that? Well, it had to be 2x and 2x. So we know that our factored version are going to be 2x minus something. And I know it's minus because there's a minus there. So 2x minus here as well. So we know our first two factors. That's pretty easy because of the 4. We learned that the two diagonals here make the linear one, and they're identical. So these need to be negative 14x because that's what half of 28 is. So what could I multiply by 2x to get that? The number that I'm looking for here is negative 7 because negative 7 times 2x is negative 14x, and likewise for this one. And when they add together, they give me this. And the way that I phrased it in class was I was thinking, what could I multiply by 2 and then double and get 28? So if you double 2 and get 4, you got to multiply by 7, right? So we know that that's got to equal 7. This is the square factor version of that in standard form. This is going to help us down here at the bottom because we know that this is going to have to equal 49 because 7 times 7. So we know that C is going to have to equal 49, and that's like our direction of how we complete our square at the bottom. So to complete this square down here that's missing a C and has a number on the other side, what we want to do is we want to add 49, so it's got that 49 in C's place. So the first thing we're going to do is we're going to add 49 to this side. We're going to add 49 to this side. That's going to give us 4x squared minus 28x plus 49. And then when we add 49 to this, we get a difference of 16. Positives win, so we get 16 there, which is nice because that's a perfect square that's going to help us out later, right? And we already know that the left side in standard form is this factored, so we can write down 2x minus 7 when it gets squared equals 16. So we are one step away from having our two equations that are going to solve this for us and tell us the two places that it crosses the x-axis. And once we get to this point, we're going to write, okay, the square root of this, which is 2x minus 7, equals a possible square root of this, which is 4. And then the other way that we could have gone was 2x minus 7 equals the other square root of 16, which is negative 4. And these two equations solved are going to be our answers whenever we get x by itself. So we add 7 to both sides. We get 4 plus 7, which is 11. We divide both sides by 2. We get 11 halves. And then over here, we add 7 to both sides. Add 7 to this gives us 3. And then divide by 2, we get 3 halves. So these are our solutions once we have solved both of the equations. These are the two places the parabola will cross the x-axis, and we did it by completing the square, not by graphing it on a calculator, although if you want to and check yourself, you can. But this is the homework I require for you to get full credit on a quiz. All right? Tomorrow, just a heads up, we'll be doing this where the answers are irrational. So our answers are going to have within them square root symbols. Ugh. So that's going to get a little ugly, but that's probably happening more often than not, to be honest, in equations that are quadratics. All right, I'll see you guys later.